6:12 a.m. It was not pager duty. It was not Datadog. It was our CFO. Can someone explain why our AWS bill projection for this month is $47,000? I was still in bed when that notification lit up my phone. Our usual monthly cloud spend was around $11,000. $47,000 was not a rounding error. It was a problem that could change hiring plans. I opened the AWS Cost Explorer app before I even brushed my teeth. The forecast line was a cliff. Compute costs had tripled overnight. Data transfer was up. EBS spend was climbing. Something had been running hard, and it had not stopped. There were no alerts, no red dashboards. Everything was green. For context, we were running entirely in AWS. Our primary workloads lived in EKS across two availability zones in US. East, 1. About 150 microservices, mostly stateless, fronted by an application load balancer. Traffic averaged around 20 million requests per day. We used RDS PostgreSQL for transactional workloads and Redis for caching sessions and frequently accessed data. Long-running async tasks went through SQS and were processed by worker pods. Infrastructure was managed with Terraform. Deployments were done via GitHub Actions and Argo CD. Autoscaling was enabled for both pods via HPA and for nodes via Cluster Autoscaler. On paper, it was a fairly mature setup. Monitoring was a mix of Prometheus, Grafana, Datadog, and CloudWatch. From a product perspective, nothing was broken. No spike in 5xx errors. No latency regressions. Customer support reported no outages. But when I drilled into costs, EC2 spend was double. One particular node group, hosting background workers, had ballooned from 6 nodes to 24. CPU usage was consistently around 70%. Not spiky, just steadily high. In Prometheus, HPA metrics showed worker replicas scaled from 15 to 80 over 36 hours. But SQS queue depth was near zero. That was the first thing that felt wrong. If the queue was empty, why were workers busy? Everything looked healthy. No restarts, no crash loops. It was like we were doing a lot of work that nobody had asked for. I tagged the backend team. An engineer replied they deployed a data enrichment feature 2 days ago for new signups. But signups hadn't increased. Traffic was flat. SQS message throughput was normal. Then we looked at worker logs. No errors, but the same job IDs were appearing repeatedly. That led to our theory, idempotency failure. Maybe jobs weren't being marked complete, causing them to requie. We checked RDS. CPU was stable, no write failures. Meanwhile, finance was escalating. I temporarily reduced the HPA max replicas from 100 down to 30. Cluster Autoscaler began scaling nodes down, slowing the burn. But we still didn't have the root cause. Then we looked at CloudWatch network metrics. Outbound data transfer from worker nodes was abnormally high. That was new. Workers aren't supposed to talk much to the internet. We pulled VPC flow logs. The top destination was an external API endpoint for that enrichment feature. It was supposed to run once per signup, but why was it running continuously? We searched logs for retry behavior. There it was, a pattern of timeouts followed by immediate retries. The external API had slowed down over the weekend, responding in 4 seconds instead of 300 milliseconds. Our worker timeout was only 3 seconds. Every request timed out just before completion. The code treated timeouts as failures and retried immediately. Each retry triggered another call. Because the job wasn't marked complete, it stayed in the loop. The HPA was scaling on CPU. More retries meant more CPU, more pods, more nodes. The system did exactly what we told it to do. It scaled. One job could be processed dozens of times in parallel. First, we disabled the enrichment feature via feature flag. That stopped new outbound calls instantly. Second, we patched the worker configuration. We increased the timeout to 10 seconds, implemented exponential backoff, and capped retries at 5. We redeployed using a forward fix. Within an hour, outbound traffic dropped. Node count began to fall. Cost projections started to flatten. By early afternoon, we were back to baseline. Total damage? $18,000. What actually failed was our assumption that retries were harmless. We had no alert on unusual outbound traffic or retry rate. No budget forecast alert. We were monitoring availability, not economic health. We also had no guardrail limiting HPA scale-up for abnormal behavior. The timeout mismatch was subtle, but our system amplified the issue. Code review had focused on correctness, not failure modes under latency. First, autoscaling without cost awareness is dangerous. Scaling policies should include upper bounds tied to business expectations. Second, retries must always include exponential backoff and caps. Instant retries turn latency into storms. Third, observability must extend beyond uptime. Monitoring retry rates, external API latency, and outbound data transfer is critical in distributed systems. Finally, budget alerts should trigger on forecast anomalies. Feature flags are not just for UI changes. They are critical circuit breakers for backend logic. That morning, nothing was down. Users were happy. Dashboards were green. But our system was quietly setting money on fire, and that is sometimes harder to detect than an outage. Don't let your dashboards hide the truth. Monitor your economic health as closely as your uptime.